Well, let's look at your questions for module 6 and 7. Juliet is asking me about 6.1, question 4. Let's see how I do on this. Do we have the same question 4?
Yes, that's
Okay.
it.
All right. So were you in class last week?
Yes, I was.
Do you remember when I made like, we had a discussion about 5 coins, and then I put down lines and I said, oh, what's going to come up on the first one? What's going to come up? That kind of approach is how you do this problem. So, but I'll do it. I'll look at it.
Okay.
So there are only so many techniques to tackle these sorts of problems. Let me open my iPad. Okay, so what is the chance that a person will correctly guess someone's 4-digit PIN number? So let's see. So you're going to have 4 digits, so 4 spots. And what are the possibilities for the first one? What could the number be?
Shouldn't it be until 9? Like there are 9 numbers?
9 digits.
Uh-huh.
Um, what about the 0?
So 10.
Right? That's a tricky thing to remember, the 0. Okay, so for binomial from here on out, 0 is a number. So yeah, it's 10 digits. So do you see now how it works? This is 10. What can the 10 possibilities can be in the first position? Well, how many possibilities in the second position? Juliet, or
So
anyone?
in this case, because it's a PIN number, it can be repeated, right? So it can be
Exactly.
repeated. Okay.
And now you see? And now we multiply.
Oh, okay.
Okay, so it's something you saw before, but first thing was to realize there's 10 digits possible and that they can be repeated. Exactly. There you go.
Okay.
So
Thank you.
it should be D. It should be D. Hopefully, let's see if I push here.
I mean, for me, it's A, but yeah, 10 a la cuatro. Está bien.
Okay, it's a different option. It's a different thing for you. Okay, yeah. Yeah, because they're randomized. Ah, it says no. Why?
It's 1/10,000, I think.
Oh, the chance, right. Yeah, sorry, we didn't finish. Yeah, we didn't finish because it's those are the possibilities, right? So there's that many possibilities. So it's 1 out of 10,000. You guys are seeing my iPad, not the thing. Okay. So that's better. Does that make sense? Because this is the 10,000 possibilities and the chance of getting it right is 1 out of 10,000. So this is like This is like the coins where you had the 4 coins. Two, 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 because it was head or tail, head or tail, head or tail. They can be repeated exactly like what we're doing here. So there's 16 possible outcomes. And if there's 16 possible outcomes and the total of probabilities should be what? One, right? The total should be 1. So what should be the probability? Each one of these outcomes right? Because 16, 1 over 16 plus 1 over 16 plus 1 over 16, it should make 1. So that's how I know it's 1 over 16. And the same logic here. So it's the same thing, really. I just have different. I just do your best to relate what you saw before. Sometimes that helps, sometimes it doesn't. Sometimes it makes it more confusing. All right. So all we found here was the number of possible outcomes. 16 was here, and here it's 10,000. So that means that each one is equally likely. So they have to sum in total. All probabilities have to sum to 1. So it's only possible if each one is 1 in 10,000 chance. I'm going to try to write a little neater. Okay, I'm excited because I was having trouble with my iPencil or iPen. Anyway, and it was the tip. Students told me that's what the problem was. I didn't know the tip goes down. So I replaced it. All right, so let's continue. Next question, any questions? Main thing is that you get through it. Let's take a moment and look at yeah, so these are the notes here. And I want to go to the very end. So this is where we left off, this discussion. Were you able to finish here? So we did this one together.
I think we see the board, not the.
Oh, sorry. Yeah, let me.
Yeah, I was going to say the same.
So in the notes, module 6 and 7, the end here. Well, we did this one together last class. Applying the rules of means and variances and the sum of variables and the difference of variables. And I kind of left off there, but I really need you to review these documents and feel confident with them. Did you manage to get through these? Who got through these no problem or have questions about these? So on the final exam, as I was saying, there's an outline for the final. I put it here in module 9. And I call it Distribución Aproximada del Examen Final. And I give you a sample exam. So these are the topics that will be covered to help you focus in your studying from here on out. So for module 2 to 5, you don't have to include this. This is a regression piece, the extra stuff. You can ignore the discussions, it's the questions and problems I give or mention. I think I eliminated most of them, but I contrast the binomial with the hypergeometric and the Poisson, but I don't expect you to know them very well. Just I want you to know that what the binomial is. That's my focus for this course. And then, because binomial is the basis for sampling theory. So you need that. And then in module 8, if you got this far, no, we're going to do that next. So you're going to omit what's this discussion of continuity correction. And so you can omit the last pages of module 9. So you omit all that, and this is the breakdown, and you'll see in the mock that there's some multiple choice problems, there's some short answer choice problems, you get to pick some problems, and then the last question are 6 points. So that's going to be out of 60 points, right? Is the test. 6 points, so 10% will come from the pages 42 to 48, and that's what this is. Okay, so I'm going to give a question similar to one of these, so you need to be pretty good at these to get 10%. All right, so having that in mind, can you take some, make sure you review those before next class, and either I can do one of the problems or we can discuss it where you had difficulty. The answers are here. Let's see. The answer are here for this one. The answer is here for this one. So the answers are all here. And the answers are here for this one. The answers are all here. Okay. The only one is we did this one together. So you have all the answers for those to study. Questions about what I just said?
Professor, I have a question. So then the final exam will also be covering the previous modules, but only with a short percentage.
Yeah.
Okay.
Yeah. And you saw where I got this, right? It's at the end.
Yes.
Okay, so that's the breakdown. And then when you're ready, you can, hold on. You can try the mock exam. The solutions are here as well. So you can practice with a similar exam to the one you'll get. And that'll be another source of solutions, questions and solutions. There's the reviews here. There's more. So you got enough stuff here to work with. Okay. So just coordinate, carve out the time to study, and you will be fine. All right. Any more questions about 6-7?
Professor, I have one question. In Module 7, there's no quizzes. Is that on purpose or?
Yeah, I just put them here. I put them, just the quiz, because we're using the same materials from 6. I just put them here. What you have in 7 is a focus on these 2 things. I didn't make more quizzes.
Got it. Thank you.
Mm-hmm. Okay, no comments, questions? You guys are used to, okay, who's still working with module 6 and 7? Or let's do it this way. Who completed 6 and 7 sufficiently? Who's completed 6 and 7? No one. Where could I go? Oh, okay, okay. Okay, so you have enough material to practice, do you think? Again, start with my videos, go through them because that is the content where I review and highlight and emphasize what's important. Okay. Is there anything? Let's see if I think I'm going to leave it to you because I really need you to ask me questions. Do your best to try the questions before you look at the answers. Because if you just read the answers, it's gonna give you a false sense of understanding. So you gotta try these without the answers. In Connect, let me make sure I have enough problems in Connect. I'm gonna check. What do I have there? Connect is again not really a good example of what I'm going to ask you on the test. It's just it's just to give you some points, some general questions. To but they're just you have to go deeper than Connect. I say it like that. Let's see what's in Connect. What I have here, I don't remember. Okay, so yeah, I have 2 more quizzes there. Okay, let me make it going to so what do you have? So these are all done. So there's two here. Oh, but they're not open, it looks like. Right? Can you see them? Or do they open for you?
No, they're not.
Oh, they
No,
should be open from May 12th. So the other day, let's see. Go back here. What's wrong with them? May 12th to June 3. Can you see it now? I mean, I don't know what was wrong with it, if there was a problem. Why you couldn't see it? Assignment.
I'm able to see them if I go directly in the classes and in the classes in the left panel, but not in the to. That's the difference.
Yeah, same.
So where do you go?
If you go to the left panel in Connect, it's different. Okay.
Yeah, I'm instructor, so it's different. But if I
Oh.
even do your student view, let me see the student view. So over
Yeah,
here,
in
you have to,
the left panel, there's a to do, the second item to do. In there, it doesn't appear, but if you go to the class, just click in the, yeah, in there, they appear.
Okay. Can they open?
You can, yeah, it says that you can begin.
Okay. Everyone check that. And both of them, 5 and 6?
Yeah,
So they've been there for a few days. Make sure you can get in. If not, we will troubleshoot, see what's going on. I want to see how many questions did I give you? Too many questions. Let's see. I got carried away here. What did I do? Oh no. I just did a couple from each. I have so many. 9, 18. All right, make sure you can get in there. Let me see the comments. Okay, so yeah, go under classes, I guess. I don't know why that's that way, but no, we know where to find them. All right. All right, so let's, what would you like? Would you like me to begin with module 8, or you want me to do some more in 7? Or I prefer to leave you more time to work with 7 by yourselves. And before I get into it, because it, you know, you need that time to find out where you're having trouble.
Profesora, disculpe.
Ajá.
Con él solamente sería una tarea que nos quedaría.
Those unison.
Hay
El
dos.
capítulo sí
That shit fire, bro. It's good.
aparece solamente uno. Si accesa en el calendario, salen los que quedan y pues tengo uno. Antes me salían 2. A mí me aparecen con fecha de entrega de junio 3. No sé si quieras verificar, cambiar, si lo cambiaste de mes.
Yeah, you have till June 3. Okay. And there's not too many problems there. All right. Not next. Okay, so I will maybe during the break I'll look at people's questions and see if there's anything outstanding. You guys, if you want to drop me an email, I can look at it during the break. I think if I get too many, I won't have time, but all right. All right, so back to my question about what we're going to do today. If you want me to start talking about binomial, you want me to go back and do some of probability that I think is important. Comments? For instance, we can do this one together. That's one thing we can try. So I guess maybe each time we meet, we can do one of these 5 problems. How does this sound? Okay. Okay, so I'll give you a few minutes. So pull up this problem. This is in module 6. You have the notes here. And scroll to the very bottom to find this. Is almost the second last problem. I have it on page 45. So have a read of that, and then we'll talk about it. Okay, are you ready to look at this? Any questions about it? Suppose that the weight of a checked luggage for an airline, so everyone's thinking about vacation now, right? Airline is a random variable X that is normally distributed with an average of 50 pounds and standard deviation of 30 pounds. Suppose that the weight of carry-on luggage is a random variable Y that is normally distributed with a mean of 10 pounds and a standard deviation of 3 pounds. The correlation between the weights of checked and carry-on luggage is negative 10%. Okay, so this information is about the big bag, right? And this is about the little bag you carry on. And why would the correlation be negative? How would you explain that? This is all given to you, but how could you justify or explain that to yourself? You can put in the chat. You can tell me. Maybe it's better to put in the chat so everyone has a chance. Why? Why would that make sense? Why would it be negative trend?
Negative, but I'm trying to like figure out
Think
the weight.
about traveling, and when you travel, what are you thinking about? You're thinking, I got to put everything in the bag, the big bag, right? And so if you put everything in the big bag, the check bag, then you have less in your carry bag,
Okay.
right? If you put everything in your carry bag and you don't really need, if you have a little bit in your check bag or no check bag, you're going to have a lot in your carry-on. So that's the negative. That they're negative. One is heavier, the other one is light. But it's not a strong correlation, right? It's 10.1 negative. So it's negative a 0.1. So it's not that strong. Does that make sense? So
Can
we're
you
talking
explain that
about weight.
Sorry, can you explain that again?
Well, it's not a strong correlation anyways, but it's negative because when your carry-on is heavy, when your carry-on is heavy, you have less in the check bag. It could be. That's what it's showing. Or if you have a lot in your carry-on, you have less in your, sorry, if you have a lot in your check bag, in the big bag, you have less in your carry-on. That would be the negative, that they're opposites. But it's not a strong relationship. It's just 0.1. Okay, so imagine that this was all figured out on the basis of a lot of data, a lot of luggage and weights were recorded, and then someone made a histogram, said it looked bell-shaped. It had approximately normal distribution with 68% of the observations in 1 standard deviation, 95% within 2, and 99.7 within 3. So they say, oh, it's approximately normal. And we're going to say that the average we calculated is the mean of this distribution, and the standard deviation that we calculate from the sample is the population standard deviation. So we will use these as our parameters. And then same for the carry-on bag. All right. Now, people often carry both, right? They don't carry just one of them. So let's look at the total of weight of luggage per person for 50 passengers. We want to make sure that it does not exceed 3,100 pounds. And what if it does? What's the chance that it does? Let's see that. So we're going to create a new variable called W from X and Y. And how do we do that? I'm just going to write down here. So the total weight of luggage, W, is equal to what? Is it just X plus Y? Is it just
Times
X
the
plus?
number of passengers?
Pardon?
Times the number of passengers?
Okay, what do you mean times? How do I times?
Multiplying.
So what do I write? Where's the times? If I give you everything, it's not going to be appreciated. So where do I put the 50?
Maybe times the number of passengers.
Where do I put that? Put it in the chat. What is W?
Well, we assign a variable what it means. I don't know if this case we already did that, but let's say X means the numbers of passengers, then we put it next to the 50X.
It's
I
right
guess.
here. It says, let's read again. It says X is the variable for the checked luggage. And it has a mean of 50 and a standard deviation of 30. And Y is the variable for the carry-on. So what is W? So by yeah, you guys, you have to do it. If I do it, it doesn't matter. I already know the answer. You have to try. Okay, so try and write it in the chat. What is W? So X is for the check bag, the weight of the check bag. Y is the weight of the carry-on bag. Per person. So the question is, what is W? W is the total weight. Total weight of all passengers' luggage. So this would be per person if I wrote X plus Y, but I have 50 people. So where do I put the 50? Alejandro and Hilexima wrote something. What do you guys do you think is correct? Can I just add up? Can I just do this? Can I just say, well, 50x, there's 50 carry-ons. Well, some of the, sorry, 50 check bags. Some of the check bags will be zero weight because people won't have a check bag. But that within 2 standard deviations, you see here that check bags could have a 0, right? There's a chance that somebody doesn't have a check bag. And Y is, these are the 50 people's carry on. So that's W. Is everybody okay with that? Ashley has a different answer with 10. You want to use this 10, Ashley? That's going to come in handy later. Right now, we just want the total weight. So 50 check bags, 50 carry-ons that have this distribution, and we're going to put them together. So this is our new variable. So this is not W, right? This is just the sum. So make sure, this is just per passenger, you add the bags together. But we have 50 passengers, so we multiply by 50. Some people wrote for 50 passengers. That was my question, where does the 50 go? All right, everybody's satisfied with the new variable we've created, and we already did all this analysis to learn about, you know, in the past, someone's given us all the results of their analysis for the data collected on check bags. Here's the analysis and the results of reviewing the weights of carry-on bags. So do we have to go ahead and re-establish what the mean and standard deviation is by collecting information on the total weights? No, we can use the rules of means and variances and sum of random variables to come up with the mean and the standard deviation of this new variable. So what is the mean of W? What was the mean of X? The mean of X is 50. What's the mean of Y?
10.
10.
Right? So what should be the mean of W? We talked about this last class. Whatever I do to the values, I also do to the mean. What are we going to do to this distribution? We're going to multiply the entire distribution of X by 50. So imagine we have a distribution of X that looks roughly normal with a 50 and a 30 here. So this is 80, this is 20. And I'm going to take every value, and I've just marked a few of them, and I'm going to multiply by 50. What will the mean become if I multiply the mean by 50? You don't have to do this every time. It's just, you have to learn the rule, right? The rule is that whatever I do to every value, I also do to the mean. So now this, it should look the same. The distribution shouldn't look any different. It's just that it's shifted over. I need to copy it to make it the same. So all of these change by 50 times. That's what we're doing. So this is going to be that big, right? And then you have to get 80 times 50, which is 4,000. So this is going to be much more spread out. So it does look flatter, which I missed. So it does look flatter because it's much more spread out. I'm just trying to get you to visualize better, but I hope I'm not confusing you. So then this is going to be flatter, more spread out because one standard deviation is way over here at 4,000, 40,000. No, it's 3 zeros. Yeah, 4,000. And then back here, 20 times 50, it's 1,000. Okay, so that's what's happening. So the mean, whatever happens to the values happens to the mean. The same thing with Y. So what will be the mean of W? So it'll be 50 times the mean of X plus 50 times the mean of Y. So we learned two things. We learned whatever we do to the values, we also do to the means. And we also learned about the rules of adding variables together. When you add variables together, when in a linear combination, either you shift by adding a constant or you multiply and spread out the values, flatten them. You also do it to the mean. So you just add all that up. So we're going to put in here, what's the mean of X? You guys told me 50. What's the mean of Y? 10. And so Ashley was kind of doing that above. That wasn't so hard, right? So do the things you can do and work with the ones that you struggle with understanding. That wasn't so hard. And it's also going to have a normal shape. So I apply these rules in module 8 as well, and talk about distributions you're going to use for sampling and inference, which are the next topics. So this doesn't go away. You need to learn these rules. What about the variance or the standard deviation? What did we learn about the variance? This is towards the end of last class that we discussed this. Right, you remember that. Okay, so let's see. Let's take some options. Is the answer is it just going to be like, I'm sorry. So this one was taking the mean, which I could also have written this, just taking a step back here. I could have also written this like this, but I kind of jumped because I don't want to write so much because I lose you when you start copying. or writing what I'm writing. Okay, so that's just 50. That is just a way to write the mean. Okay, so can I just put this like this? 50 Vx plus 50 Vy? That was the nature of the conversation we had. What's the spirit of it? Can I just do that? Or no? I think Simar is on the right track. So the rule is, I'll put it here. So if you take X and you multiply it by a number and you add another one, you just get the same. Whatever you do to the values, you also do to the mean. You see the pattern? And the other rule was that if you take two variables, then it's just going to be a mu x. Okay, I'm running out of space. Let me take this away. These are just reminding you of the rules. I'll just reference, I'll tell you to go look at the rules again, because I don't want to go on a tangent. So I talked about this before, right? This is whatever you do to the values, you also do to the means. And then here, when it comes to the variance, it's not going to be this exactly. The rule for variance is it's similar, but different. You got to take, first of all, these need to be squared because of the fact that when I calculate the variance, I square the deviations from the mean. So I end up squaring everything. I square these weights or these values that are these scalars in front of the variable. So this gets squared. And then there's another term. The other term is 2 times 50 times 50. So the weights get multiplied and then times covariance x, y. That is the rule. It's not this. Okay, now if the covariance is 0, then this falls away and it looks similar to this, but you still have to square those two values there. All right, so what do we have here? Do I have Vx? Do I have Vx? Do I have the variance of x? What's the variance of x?
Terry,
Say it again?
is it Terry?
Nope, but it's similar. It comes from 30. Variance is, what does variance mean? Standard deviation squared, right? The variance is the standard deviation squared. So you got to square that value in here.
Yeah, you're right.
So this is going to be 50 square times 30 square plus 50 square. Okay, what about y? What's the variance of y?
3 squared.
It's 9, right? Okay, 3 squared, very good. 2. Now I just keep going. And what is the covariance of XY?
Negative 0.1.
Okay, let's go back. So there was extra information. I didn't put it here, but let's put it here. So the information was that correlation, the correlation was negative 0.1. Is that the covariance? Is that the covariance?
I think you have to do the, I don't know how to, you have to multiply it by itself because you have to do the square, I think is it.
Okay, let's say, recall from module 5. What did we learn? We learned that R was equal to covariance divided by standard deviation. Um, Standard deviation, what did I write for that? Oh yeah, SX. You remember this? So if someone gives you the correlation, how do you get the covariance? Do we have the standard deviations? So can we get the covariance? Yes, Maddie's all way ahead of us here. My question is, what is the covariance?
Well, it's the multiplication of R with SX and S squared.
Right, Juliet. Good, good. Okay, so this is not so hard, right? Once you know, this ties it all together. So I do give you another formula where I put the correlation in there instead, but it comes from doing this, so I might as well just do it here. The other formula is just a matter of doing what we're doing right now. So covariance is, like you're telling me, negative 0.1 times 30 times 3. So what do you get? Some people got it already. Great. Negative 9. That's it. I'm going to put that in. Don't forget the negative. And put it all together. Okay, so put it all together and then let's go back and discuss any confusion. And while you're doing that, putting it all together, I'm going to just write in here the rules. Okay, so this is not so pretty. So these are the rules, right? Whatever I do to the value, the variable, I also do to the mean. So that's the rule in general for a scalar and a scalar multiple on it. So that's called a linear transformation. What if I add two variables together? Whatever I do to the values, I also do to the mean. What about when it comes to, so this is just A and B. These are just, constant values. What happens to the variance? Okay, first I begin with the standard deviation because this one is simple. But this comes from the reality that if I have to take a linear transformation, the shift doesn't matter. Shifting of distribution doesn't affect the spread. So we don't even care about that. This is really the result. And so because it's all squared, I can just write it this way, okay? So I have two different ways of writing that. This looks so much more simple. This kind of stuff, put it on a sheet beside you and, with the formula sheet that I'm going to introduce in module 8 that I refer to a lot in preparing you for the final exam, you can add this kind of thing there so you remember. So this is, if you take a distribution and you multiply it and then you shift it, the variance or standard deviation is only affected by the multiple, not the shifting effect, the adding or subtracting. And that comes from the fact that if you were to get the variance, you'd see that the value in front of every value, like I showed you last class. If you were not here last class, look at that video and I demonstrate why this is a square and then this is a square too here. Okay, so basically I don't have to do an analysis of the new distribution. I can just use the one I have and it's just a very simple conversion. Whatever I do in terms of multiplying the values, I also do to the variance squared. And then this rule here. So these are the general rules, but then I make some variations on this formula here, but that's the formula for variance. It's that taking these two from here, and then there's an extra term, and this is the covariance here. So those are the symbols that I use because they just seem more efficient, less strokes of the pen. And that's it. So now we add these all together. And you guys got a number for me? Take your time. I'll do it with my calculator, show you how I put that in. You can do it in Excel, on a cell of Excel. So if I add these together and my calculator is in, the one I asked you to buy is in AOS mode, it means it's in order of operations so that all I have to do is multiply 50 square times 30 square plus 50 squared times 3 squared, just be careful, plus 2 times 50 times 50 times 9 negative. There you go. And yes, Mari already showed us the answer. So try it yourself. So what we found out is the mean and the variance of the total baggage weight for the entire over all 50 passengers. It's a small plane. So if you're just, remember you can go back and watch the video to fill in your notes. The most important thing is that you follow along. If I'm going too fast, let me know. Don't get caught up in copying because all of this is available in the notes and in the videos. So my final answer is 2,277,500 total weight in pounds. Variance. Oh, it's lots of variance there. So it asks for the variance, not the standard deviation, but I guess we could do that too. What's the standard deviation? Because it's more meaningful in terms of pounds. Because variance, remember, we can't say units. We can't attribute units. So 1,492 pounds. You can't do that here, right? Because variance has units squared. We don't talk about that. Okay, so we did it. Now what? Next step. Next question. Okay, we want to figure out, now we have the mean and standard deviation. So this is what we do every time, right? We identify the variable. We look at the distribution. From the distribution, we learn what is the, what are the parameters of the distribution to make predictions. Now, we were given information on a normal distribution, two normals, we add them together, we find their mean and standard deviation, and now we can answer questions about them. The mean was 3,000, and the standard deviation is this over here, but I can leave it in the squared version, but those are the main things that we need. So now we're going to figure out what's the probability of exceeding the probability that W is greater than how much? What did the question say? Let's read again. Let's go back and read it together. All right, so we did all of this. We understood there are two bags, 50, two kinds of bags. This one with 50-pound mean and standard deviation 30, the other bag with a mean of 10 and a standard deviation 3, and there's correlation that's negative. And from there, we got the covariance for the formula. And then we added these things together, and we want to know, this is the question, that does it exceed the limit? Okay, so does the total weight exceed the limit? So is W, what's the chance of W being more than 3,100? That's what we want to find. Very good. Eliximar said greater than 3,100. All right, so let's go back to my iPad and do it. So what do I do? We are making the leap that where W, let me write it, W is also normal. So if we add normals together, we get another normal. I'm going to talk more about that in module 8. But that's what we're assuming here, right? That we had we had two normals, we added them together, multiply them by 50, and we get another normal with 3,000 and a mean and 1,492 standard deviation. Or we can leave in, we can leave it like this so we don't lose any decimal places. We're going to leave it like that. And now we're going to standardize this. So I guess that's the missing part is I don't think I mentioned that. That's what we're doing is that when you add variables together, like we did here, multiply them, and they were normals, the sum of them, the linear combination and the sum of variables that are normal is just also normal. Okay, so that's what we want to find out. So let's standardize this. When we standardize this, this becomes a z, and then we take 3,100 minus the mean. So we're going to minus the mean and divide by the standard deviation, right? So this is 3,100 minus 3,000 divided by standard deviation of 2,277,500. And what do you get? I'm counting on you to calculate it. Did I do that correctly? Did I do something wrong? Let's try that again. 3,100. And then you have to look that up. And we want to go here to 0.06 or 0.7, right? Because the table, the Z table only gives us 2 digits. So really, I'm going to look up. Let me move this over a little bit because it looks like 0. Zero. And you want to go this way. What do you get? So lots of material here is being combined in a question. All right, so you're having the normal distribution rules from module 3, 1, 2, 3, 4. From normal distribution module 4. And then you're also having module 6 information and module 7 information. Let's see. What's the chat say? Two. Let me do my standard deviation again. I didn't use 1492. I used the whole number.
Profesora,
Yeah.
yo no sé, pero en mi calculadora cuando yo saco, o sea, ya usted lo hizo, pero intenté hacerlo en diferentes ocasiones, pero cuando saco la
yeah.
raíz cuadrada de los 2.277.000 con 500, no me da 1.492, me da
Yeah, it's just a mistake. I probably have a mistake. Let me see if I missed a number. Let me do this again. If I put a different number, I'm gonna check.
me da
227.
1.509.
22. Oh, I missed a 2. That's why. I missed a 2. That's why. Yeah, I was right. I wrote down Yasmati's number, and I should have written down the right number. She missed the 2, and then I missed the 2. This is a 2 here. And then pretty sure I had it on my calculator though. Let me try it again. The numbers look so similar. 50 square times 30 square plus 50 square times 3 squared plus 2 times 50 times 50. I'm just trying to write exactly what's there times 9 negative. To see there's the extra 2. And then when you take the square root, you get 492. So there we got our problem. But thank you. So I just transcribed incorrectly. This is a 2. 2, 2, 2, and this is a 2. And then I'm gonna get I'll get the right answer here. This is a little bit off. Okay, are we all on the same page? So 3100 minus 3000 divided by 2227500. You get the 67. Anyway, you saw even with that, it was similar answer anyway. It's you're not going to be way off. I think the approach I use for probabilities keep 4 decimal places. And you will get the same answers as me. You don't have to worry about having different answers. But when it comes to using the normal distribution, there's only you only have 2 digits in the tables, right? So when you do this, 0.07 is all you can look up anyways. So even with that mistake, didn't. Alejandro, I don't know. I don't know if you follow what I just did. I just had a typo here because I was transcribing, not from my calculator. I took it off the screen and I made a mistake. Okay. So looking it up now, last step. Try that one. Without me. On your own. In the end, it didn't matter for this problem that I wrote a 7 instead of a 2. So what are you doing? You're going to the tables? We're going to go onto the positive table and look for 0.07, which is here. And what does this give me? 0.07, that's not 0.07. 0.07 is over here, right? Be careful. Yeah. That was 0.7. This is 0.07. 5279. You can also put it into Excel with more decimal places to get more precise. But if I use the tables, yeah, it's just 5279. And what did I find? I found this side. No. 5279 is going this way. It's a little bit more than 50 because we're just a little bit to the right of 0. And so this is 1 minus. And you get 47. So the answer is what? What's the final answer of all of this? What's the conclusion? What's the chance that the weight will be exceeded? You guys put it in words in the chat. What's the chance that the weight will be exceeded? Right, you're putting the number, but in words, palabras. There's a 47% chance that the weight will be exceeded. It's a high chance. It's a really high chance. So they got to figure out what they're going to do about that. Okay. Especially if it affects a malfunction or affects the functioning of a plane. All right, so it's 10:30. We finished that. Do you feel good about that? Where did you go wrong? Lots of material. That's a really good summary question, applying everything about probability, normal distributions, and then rules of means and variances. Brings it all together. Okay, so next class, I think I'll do another one, a different one. You guys should look at these because it's going to be really tedious. I think that's the most interesting one. The rest are just calculations. Okay, good. I'm glad you feel better about this type of problem. So yeah, one at a time, go through them, feel confident. I might change some of these numbers in the problem. So I could change some of these numbers, have a different storyline, but you should be able to do the same sort of thing. Okay. All right, and there's the answer. So even if I made a typo here, it didn't affect the same, I would have gotten the same answer. Okay, so there's a few more. 1, 2, yeah. It's just 2 more. I'll let you guys look at these and build your confidence. All right. So keep working with 6 and 7. Let's talk something about 8. Let's do some 8. So 8 focuses on the binomial distribution, which I introduced last week and you've been reading about. And what we really want to do with the binomial now is derive the formula for the binomial and apply it with different examples. So you need to be able to identify a situation that is a binomial setting, apply the formula to solve the problem. Last week, I showed you how to generate a binomial distribution in Excel. You can go back and look at that, and you're free to use that technique, but I do need to teach you about where it comes from. So first, though, I think that's going to be throughout the videos. First, I want to do this exercise where we talk about what is a binomial. Has anybody started this? I'm going to presume no. Has anybody started module 8 yet? Here I derive the binomial and then I just apply it. I spend some time deriving. That's all we do. But let's spend some time first talking about what is a binomial. Okay, not yet. I thought I had it here. It's in another place. Let me find it. Okay. Okay, do you remember the discussion we had of what is a binomial? Let me put that up first, and then we'll go to the... So from in here, in module 6, in the part where here I discuss binomial. These are the criteria for a binomial. Remember this? If you can express the variable as a counting variable, you're counting the number of successes out of n independent trials. So the possible outcomes are the 0 up to n could be what you're looking for. 0 to n successes. So either when you're looking, you either find a success or a failure. You know the probability of seeing a success, that's criteria 2, and you know the number of times that you repeat the incident or repeat the experiment or the event. So knowing that, I want you to consider, where'd it go? Okay. These different problems. So let's look at this. And which of these are examples of a binomial distribution or a variable that is binomial? So I'll give you some time to read those. What you should be able to do as you read them is identify the success, identify the probability of a success, and identify how many attempts you will make to find the success. Okay, if you can find those things, then you have a binomial. So read those, and I'll give you, let's take 5 minutes, take a break. Okay, I'm gonna pause the video. All right, so how did it go? What do you have to say? Are you back? Come back. Which one of these has a binomial distribution? There are 5. Only one of them has a binomial distribution. Which one do you think it is? Yeah, just write them in the chat. Since the popular one is B, let's begin there. An airplane carrying 100 passengers has 2 emergency exits. See, all this stuff about travel. I'm talking about planes and luggage. Travel is in the air. Anyway, an airplane carrying 100 passengers has 2 emergency exits, one at the front of the plane and one at the back. The airplane makes an emergency landing and people exit through the door that is closest to them. X is the number of people who leave the plane through the front exit. Okay, so it says number, so maybe it's a binomial. So we need to define what is a success. What are we looking for? And how many out of how many? So first of all, what's the success? What are we looking for? What are we interested in counting? How would you write? How would you express it in words?
The people that come out through the front exit.
Okay, yeah, exactly. Very good. So then the people who come out, the success is exiting from the front, right? Exiting in short words. So you can use a long sentence if that makes more sense. But basically in a few words, the success, I'm just writing in the chat, is exit Passenger exits through the front. What's the other thing that can happen? What's a failure? What's the opposite event or the alternative? Right, through the back exit, through the rear, right? So the success is exiting from the front, the failure is exiting from the back. Aha, so it sounds like, okay, so we have a success and failure. Okay, so we have a
Professor,
success
if
and
you're
failure.
writing something, we're not seeing the.
I'm putting it in the
thing.
chat.
Okay, got it.
Sorry, I'm putting it there so I can keep this open. All right, so I put it in the chat. All right, so everybody understands success and failure? Okay, so that sounds good. All right, now, what is the probability of a success for each passenger? What's the probability of a success? What's the probability of success? Oh, that's a leap to say it's 50%. La Nieska. Did I say that right? Nieska.
Janishka.
Ineshka. Okay, great. Beautiful. Beautiful name. So you guys are saying it's 50. Okay, so you're sitting on the plane. Think about sitting on the plane, visualize you're going to Bahamas, you're going to New York, you're going somewhere to Europe. And if you sit at the front, what's your chance of exiting through the front? Is it higher than if you sit at the back?
Yes.
Okay, now I'm going to ask you the question again. What's the chance from exiting from the front for each passenger? It changes, right? It depends. Now it depends all of a sudden. It's not 50-50. It's not like a head and tail. So you sit at the front, you're more likely to go through the front. You sit at the back, you're more likely to go from the back. So what's happening here? What's the problem? So the probability of success is called P, the little p. I'll write it in probability. The probability of success is called P, and P is supposed to be one number that stays the same for every single passenger, but that's not the case, so we have a problem. That's why B is not a binomial. P changes depending on where you sit. Okay, the little p. So you guys all agree now, P is not a binomial, so it has a problem with the P. We know the N, so we have to identify the P and the N. The P is a probability of a success, and it should not change. It should be the same for every trial. There are how many trials here? Hundred passengers. So there's 100, right? So trials N equals 100, but probability of success is not constant. It's not fixed. Okay, it changes. It's different. Okay, so did I convince you B is not a binomial? So we have to try the other one. So now go back to the drawing board. Which one do you think is a binomial? B is out. Okay, Jennifer's picking one. So make sure you write down what I'm putting in the chat or you're not gonna get it. I guess I could put the chat I think I can post the chat with the video. I'll remember to do that. Put your selection in the chat. Okay, some said C, some said D. So the goal is to first find what is it that you're looking for. Define success, make sure it fits the framework of the number of successes and end trials, and then look for P, the probability of success, and the number of trials. P must be known, or you could calculate it, and should be constant for every single trial. And N should also be known in advance. Okay, so I have a few guesses. Some people given up or they left. um, let's see how many people are still here. Yeah, you guys are here. Okay, so let's see. So some people said D. Some people said A. Okay, let's look at this then. Okay, so let's start with D, looks like more popular. So D. Okay, you randomly select 5 cards from a standard deck of cards which contain 13 hearts, 13 diamonds, 13 clubs, 13 spades. X is the number of diamonds selected. Okay, so what is a success in this example? Or this option? Define success. Right, very good. Diamonds, diamond, getting a diamond. Okay, so selecting a diamond or a diamond is a success. And then what's the chance of a diamond? Okay, so 13 can be diamonds out of 52, so that's the chance of a diamond. 13 out of 52. Or yeah, it's a quarter, right? Because half, sorry, there are 4 different suits. Okay, so that's what you think. Who thinks differently? Who thinks differently? So imagine taking a card and you got a diamond. You're holding a diamond. What's the chance that the next card will be a diamond? Is it still 25%? I didn't shuffle the deck. I mean, I didn't change the deck. I used the same deck. What happens to the next try, the next selection? We are not returning the card to the deck. We're going to select 5 at the same time, basically. Or like 1, 2, you know, and take 5 out. So we're not returning, no replacement. So that's very important. If we return it, we have the same scenario every time. But if we keep the 5 card, or we take 1 and we keep taking cards, we don't put it back each try. We do not have the same scenario each time. So our probability of success, the probability of diamond changes with each selection, depending on if we had a diamond or not, right? So probability of success the probability of success change, the P changes for each card that's drawn. All right, so the P is messed up again. So P it's not constant. Constant. All right. And so what next? So it's not constant. What about N and D? We know N is what? It's 5. Why am I talking to myself?
Well, N changes because every time that you draw 1, since you're not returning it, then you're reducing the by 1.
N is just the number of trials. It's not necessarily the sample draw.
Oh,
Yeah. So
okay.
that's good I asked the question. Yeah. So yes, the number of cards will change for sure each draw, but that affects P. It doesn't affect the number of tries. So there are 5 cards, 5 tries.
Got it. Thanks.
Thank you. And all right, so we've destroyed B, we destroyed D. Okay, what's next? I think the other one was just C, right? Let's see. Oh, someone said A. Oh, let's talk about A. Okay, what is this? What are we looking for in A? What's a success? Yes, getting called, right, Aisha. Getting a call. Okay, so Juliet has a little more detail in there. Getting a call went from 9 to 5. I guess that's still good. Yeah, a call from 9 to 5. Okay, so success would be that. Now, what's the probability of success? What's the probability of success? What does it tell you? A 911 operator works one day from 9 until 5. The probability of a call is known. Okay, so when it says that, I don't have the number, but they tell you it's known. So that's not an issue. So probability of a success, known as P, is known. Okay, so that's not the problem. Let's go for N. What is N? Okay, unknown, right, Juliet, Eliximar. There's no N because the number of calls can vary. So it's not really defined. It's not defined. It's not finite. There could be, I don't know. We don't know. We don't know how many times we're going to wait for a call. Basically, you could count the minutes or the seconds. It's not clearly defined. Okay. So N, the number of times we're going to look. There is an interval 9 to 5, but that's not a discrete number of trials per se, right? Also, anyway, it's not clear. Okay, so it's not clear. So N is the number of calls or number of trials is unclear, not well defined in a finite or discrete way. So it's not good. This is actually an example. A is an example of a Poisson distribution. And the P in this case that we found is used to make estimations. And like I mentioned before, there's different kinds of distributions. I just want you to know them in that they are not binomial. Clearly, this is not binomial because there's no clear N, the number of trials. We have a window, but that window of time, it's not clear how many calls could be received in that time to be able to count them. It could be 100, it could be 3, like we just don't know. So N is not defined, it's not clear, it's not finite or in any discrete way. So that's why A is out. All right, so we destroyed B, D, A. And none of you picked E, right? So do you guys see what the answer is now? Some of you saw it before. So what is the answer? Which one is clearly a binomial? So for the one that you think is clearly a binomial, put it in the chat. What is the N? What is the P? What is the success? So success, P and N. Put it in the chat. Make yours unique. Don't copy others because they might be wrong. So let's see. Still thinking. Okay, so Jennifer writes, probability of success is blood type A. So success is type A. I'll fix that a little bit. Okay, so there's 25 trials, which is correct. And the chance of A, well, we don't know it's 50, just it's known, okay? So you're going to see some examples I'm going to present to you with blood types, and it's not necessarily 50%. But it's known. So you can just say P known. So let me fix this. So probability of success. So first of all, success is, and thank you to Jennifer for trying, writing in there. No one else wrote. Success is blood type A is true. Blood type A. The probability of success equals P is known. Well, I don't know what it is, but it says it's known, so it's defined. It's known. It's finite. And the number of trials, we're going to look how many times at 25 different Puerto Ricans. So yes, C is the right answer. Okay, so C is the right answer. C is a binomial. E is not. What's wrong with E? Is it, so what's wrong with E? What's wrong with E? Why isn't it binomial? Okay, so what's wrong with E? Okay, so let's try and write it up. Okay, so let's try and write up no, sorry, success. What would be the success in this one? What are we repeatedly looking for You toss a pair of fair dice, number of tosses. Oh. So there's a problem here, right? We're focusing on the number of tosses to get something. That's not what we want to do. We want to repeatedly do something. The end needs to be clearly defined to look for that something, right? We're going to repeatedly perform or repeat a setting or an event, looking every time for the same thing. In this case, we don't know how many times we're going to do that. We're looking for something, and here it's like success is looking for a sum of 7. But the problem is the probability of a success, we could calculate that, right? We could calculate the probability of getting a success, but again, here is the problem. The problem is number of trials is not defined. Okay, you don't know what it is in advance, and is not known. Okay, so it's just not known. All right. All right, so A, I told you, is like, it's known as a Poisson distribution. That's not binomial. B, I don't have exactly a definition for this kind of a distribution, but you could derive one, but the P changes. It's not binomial. It's not the usual one. C is a binomial. D is known as a hypergeometric distribution, where there is no replacement and the event setting changes the probability each time of getting what you're looking for. So that's related but different than the binomial. And this last one is not a defined distribution that I'm going to label, but it's also not a binomial. Okay, so you have to have P known, or that you can calculate it. You have to have N in advance of conducting the trials. Otherwise, you do not have a binomial. Any questions about that? Does that help you understand better the binomial? Is that useful for you? I'm going to put this up on the platform. I believe I discussed it in the videos for this unit as well. You can see it again. I'll have another example that I go through. Just making a note to put up this document. All right. Good. All right. So, what next? It's 11:20. We don't have too much time. All right. So the beginning is talking about this formula. This is known as the binomial formula, and I derive it. And once you see it, it's pretty straightforward. Next week, I'll solve some problems if you didn't have a chance, but I hope you have a chance to go through this. It's very easy, actually, and there are many problems to attempt. And that's it. That's it. You just learn the binomial and answer all these problems. And as I said, you could use Excel as well. So you have the instruction on how to develop that. I talk about binomial tables that now you can develop yourself with Excel. This is the code. And practice assignments. Oh, here's blood type. These are the distribution. So this is the different kind. These are the different kinds of blood type and their probability. So actually A blood is 34%. O blood is 51%. B blood is 12%. And AB is the smallest 3%. And I, of course, am the smallest. I don't know if you know your blood type, but I know my blood type. So then you solve all these problems, and then I get into the second part. So this is also very, very easy. You need to get through it though. Watch the videos. I do have here video page by page for, yeah, some instructional videos here on solving the problems. Feel like there's a video missing. They're all pretty short. Oh, this is kind of long. Homework, lecture notes. Ah, here it is. So these are the lecture notes, 16, page 16, 17, those 2 pages there. I should probably separate those. Oh no, 31, 32. So these are actually instructions from the lecture notes that I want to make explicit for you to review. And those are apart from the videos here, but I might mention the material there as well. All right, so any questions? I'm going to let you go today. I mean, you're free to go. I will look at all your emails and make sure that I've addressed all your concerns. I'll be in touch with you by email. If any of you want to meet with me during the week to clarify anything, we can meet in a virtual meeting or a virtual call. Just keep me posted. Okay, so continue with your review of the material. Next week, you should complete module 8. So this weekend, I guess you'll have to wrap up with 6 and 7 during the week, module 8. And so next week, I'll answer questions you have about module 8. And we will have the last 2 weeks to talk about normal distributions. Inference. Inference, not normal distributions, inference. Normal distribution comes back strong with the inference unit. Actually, it never disappeared. We deal with normal distribution throughout. And it is really the more foundational chapter or module is module 4. So if you didn't learn module 4 a while, you need to go back and work on that because it's the foundation for everything that we do next. Okay, any comments, questions, concerns? Okay, so have a good weekend, have a good week, and keep me informed of your progress, okay? I don't want you to fall behind. We're in the home stretch. Bye-bye. Thank you.
Thanks. Have a great weekend.
You
Thank
too.
you.
Bye.